I am Dr. M. Tamil Selvi, Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. Course material of Engineering Geology's topic is Engineering Importance of Fold, Fault and Joint. Tunnels or underground passage routes through hills, mountain, earth crust used for different purposes. These passages are made by excavating rocks below the surface or through the hills and mountains. The effect for tunneling on the ground. Deterioration of the physical condition of the ground is the common effect of tunneling. This happens because due to heavy and repeated blasting during excavation, the rock gets scattered to a great extent, develop numerous cracks and fractures. The reduces cohesiveness and impactness of rock. The rock conditions, the earth crust or underground rocks are under great pressure, or they will be association with some geological structures like folding, will be a equilibrium stress. When the tunnel is created, such rocks which are equilibrium get disturbed, resulting in the collapse of the roof. Frequent bursts may also occur. This phenomenon of fall rocks, brittle and hard rock is called popping. Due to tunneling, the overlying rocks deprive of support from the bottom and they may become unstable. Such unstable conditions become still more precautions if the tunneled beds are incompetent. Overbreak. Due to tunneling, the excavation normally involves the removal of extra rocks or matter around the tunnel. The quantity of rock broken and removed in excess or what is required by the perimeter. In the case of sedimentary rocks, the orientation of bedding planes, the thickness of beds or with respect to the alignment of the tunnel, geological factors influencing the overbreak. Homogeneous nature causes less or overbreak than harder rocks with well developed joints or weak zones. In sedimentary rocks, thin formations, those with already hard and soft strata produce more overbreak. This because during the excavation, softer rock yield more than hard rocks. Roads. The roads are considered road alignment. Dip and strike, joint, fault. Dip and strike. There are three cases of consider under this category. Road cut parallel to dip direction. In this case, strata will be offer uniform behavior on either side of road cut. And road cut parallel to the strike. Strata layer plunge or dip inside the road cut. Strata dipping into the hill. In the case of slope of ground cut, road cut will be unequal on both sides. This situation would result in similar difficulties as raised in cuts parallel to strike. Road cut inclined to dip and strike. In this case, the slope of road cut will be unequal on both sides. These situations would result in similar difficulties as raised in cut parallel to strike. Weathering conditions, groundwater conditions, dam on various Google strata. The strength of sound unfractured stratified rock is always greater when the stresses are acting normal to the bending planes than if applied in other direction. This being so, horizontal beds should offer best supporting for weight of the dam. But as it's shown in a later section, the resultant force is always inclined downstream. The most unfavorable strike direction is the one in which the beds strike parallel to the axis of the dam and the dip is downstream. It must be avoided as far as possible. Therefore, other conditions being same, beds with upstream dips are quite favorable sites for dam foundation. Dam along upstream side and anticline. Dam along downstream side syncline. Fold. Unfavorable situation of civil engineering project. The downstream side of anticline, unfavorable dam project because there will be loss of water to reservoir due to seepage towards the downstream side of the dam. The upstream side is syncline.